Alright, so we're doing factor theorem, remainder theorem, rational root theorem. We've got some vocabulary here at the front. The top of this page, long division, you know that what you're dividing by is called your divisor. What you're dividing into is your dividend, and then your answer is called the quotient. If you look at it synthetically, then your divisor is the solution. And then you have your coefficients of your dividend. Your answer's going to be down here, so called the quotient. And remember that the last number is your remainder. The factor theorem and remainder theorem says that if you synthetically divide, so over here in the red, and the remainder is 0, then your divisor, so A, is a solution of this polynomial, and its factor is also a factor of the polynomial. If you don't get 0, then you just found a point on the graph. The rational root theorem says that the possible rational roots, it won't be all of them, but these are the possibilities, are the plus or minus the factors of your constant term of your polynomial, we call those P, divided by the leading coefficient factors we call Q. So let's look at some examples, if we could. Alright, so we want to see if, in fact, x minus 2 is a factor of f of x. So we can have two methods. We can evaluate and or we could do synthetic division. So to evaluate, we're going to take our factor, x minus 2, set it to 0 and solve. We're testing out to see if the solution x equals 2 is in fact a solution. So we're going to replace all the x's with a 2. So when we do that, 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6, we get 0. Which means, yeah, x minus 2 is a factor. Because we got this 0. 2, 0 is an x-intercept. 2, 0. Alright, let's see if we could do this synthetically. Again, we're going to be using the solution. So again, if we take our factors set to 0, x equals 2, and then we want to write down our dividend. Those are going to be the coefficients of f of x. We do want to make sure that our exponents are all accounted for. Your exponents need to go down by 1 each time. So 3, 2, 1, and then we have x raised to the 0 power. So we're good. So let's look at all of those coefficients. So 1, 2, negative 5, and then negative 6 are what we're going to use. And to synthetically divide, the first thing you do is you bring down the first number. And then we multiply. 1 times 2 is 2. And then we add. 2 plus 2 is 4. Then I multiply again. 4 times 2, 8. Then I add. Multiply. 3 times 2. And then I add. So there I get my remainder is 0. So this would be yes again for the same reason. X minus 2 is a factor. I got a 0 in my remainder spot. 2, 0 is an x-intercept. Okay, we can see this graphically. So let's go to our calculator. So if I type in my function of f of x here, I can see my graph. And we were testing to see if in fact, is x equal to, or is x minus 2 a factor? Well, here it is right here. It goes through at 2. So yes. Alright, here's another example. We're going to use the same f of x. So now we're testing to see if 4 is a solution. So if we were to use evaluate, I'm going to put a 4 in every place that there was an x. Notice now it tells me what the solution is. So I'm really testing x minus 4 as being a factor. They're almost the same question. So now if I replace all the x's with a 4, I get 70. I didn't get 0. So the answer here would be no. Since I didn't get a 0, x equals 4 is not a solution. I would know that 470 is a point on my graph. But it's not an x-intercept. We can do this synthetically. Again, make sure that your exponents go down by 1 each time. So 3, 2, 1, nothing. So that's good. We use our coefficients. 1, 2, -5, and -6. Bring down the first number. Multiply. Add. Multiply 6 times 4. Add. And then multiply. So our remainder is 70, not 0. So the answer is, again, no, x equals 4 is not a solution because the remainder is not 0. I would still know, though, that 470 is just a point on the graph, but it's not an x-intercept. Okay, we can also list the possible rational roots. Possible. So we're going to take our leading coefficient, we're going to write down all the factors of 2. So plus or minus 1, plus or minus 2, and then we're going to list all the factors of -12. Plus or minus 1, 2, 3, 4, all the numbers that'll go into 12. 6, and then of course 12. We call these P's and these Q's. And so our list will consist of P over Q. So our solutions, our possible solutions would be 1 over 1. So that's just 1. And then 2 over 1. 1 over 2. 2 over 2 is just 1, so I don't have to write that again. 3 over 1. 3 over 2. And we have 4 over 1, which is just 4. 4 over 2. Well, 4 divided by 2 is 2. We already have that down. I don't have to write it twice. 6 over 1. 6 over 2. 6 divided by 2 is 3. I already have that one down. I don't have to rewrite it. 12 over 1. And then 12 over 2. 12 over 2 is 6. And I've already got it down. So again, I don't have to rewrite it. So these are the possible rational roots. Not all of them. But if one does exist, if one rational root exists, it has to be one of these. Alright? So don't forget your Google form. I put some, if you click the wrong answer, there will be immediate feedback for you. And I hope that you took some good notes. I'll see you in class.